This is a review of how to put numbers into scientific notation and take them out of scientific notation. So the first set of problems we have here gives us an example. It says that we have 156,310,000 kilometers. Since this is a very big number, it would be more convenient to write this in scientific notation than rewriting it multiple times and possibly even writing the incorrect number by copying it wrong. So what we can do is, to change it into scientific notation, we're going to move the decimal point so that the number is between 1 and 10, and then we're going to add an ending times 10 with an exponent that's going to tell us how many places we had to move our decimal point. The first thing we should do here is notice that we don't have a written decimal point in our number. We can assume if we don't have a written decimal point, then the decimal point is actually located after the very last zero. And so once we've decided that, we can take that decimal point and we can move it so that the number is between 1 and 10. The usual place we'll end up having to move the decimal point to is after the first digit that's not a 0. So what I'm going to do is make loops under each of my digits, counting as I go. In this number I had to make 8 loops, and so I'm going to write my answer here as 1.5631 with my decimal point in its new location that I moved it to, times 10, and I'm going to add an exponent that's equal to the number of places I moved it. If I had to move my decimal point to the left, which I did here, I'm going to make this a positive exponent. But if I'd have had to move my decimal point the other direction, to the right, I would make it a negative exponent. A general rule we can follow is if the number itself to start out with was larger than 1, then we're going to have a positive exponent. If it was less than 1, we should have a negative exponent. We can also take numbers out of scientific notation as seen in my second example here. In this example, I have the number 6.751 times 10 to the negative fifth power. Now, I know from my example before that if I have a negative fifth exponent on my number, that means that the number that I end up with here as my answer should be less than 1. And so what I'm going to do is I'm actually going to move my decimal point to the left, the opposite direction that I would have had to move my decimal point to get a negative exponent in the previous example. And I'm going to move that equal to the number of places in my exponent. Now, I do have some empty loops at the beginning, and so I'm going to fill those in with zeros. And so my answer here, I'm going to put 0 point, and then I have 4 empty loops, so I'm going to put 4 zeros, 6, 7, 5, 1. And I should make sure that any time I'm writing one of these problems, if I have a unit, that I add it.